So friends, this is our robot. This is a prototype. This robot is combined of both metal detector and fire extinguisher robot. Bottom section of the robot is metal detector and upper section of the robot is fire extinguisher robot. Actually there is no communication between metal detector and fire extinguisher circuits. So first we have to fix wheels. For that we want BO motors. Here we are using 4 BO motors. Right side of the robot, front and back motors has combined together and make a single supply for both motors. So as left side of the robot, motors are connected together and combined both 2 BO motors make a single connection. Finally we got 4 terminals. From right side 2 terminals and left side 2 terminals. Right side 2 terminals will be connected to the output 4 and output 3. Here the both terminals are connected to the L29 3D motor driver. It has a 4 output ports and 4 input ports. Now move on to the metal detector circuits. Here some components are used in to develop the metal detector. Arduino, copper coil, diode, 10 nanofarads capacitor, buzzer, 300 ohms resistor and breadboard. First of all go through the Arduino. It is a microcontroller board that controls the metal detector circuit. It is responsible for processing the signals generation by the coil and outputting the result to the buzzer. Next, move on to the copper coil. It creates electromagnetic field when the metal object is placed in the medium. It includes eddy currents in the metal when produces a magnetic field that will be detected by the coil. It is used to determine the presence of metal. And move to the capacitor. It is used to tunnel the metal detecting circuits that specific frequency. Here the capacitor is used to tunneling the required frequency to the circuits. In this circuit we are using resistor. Resistor is used to limit the current flow through the circuits, and also we are using diode. Diode is used to protect the whole circuits from the reverse voltage. For the indication purpose we are using a buzzer sensor. Buzzer is used to generate a audible alarm. For the metal detector circuits we are using a 9 volts power supply. So here this is the fire extinguisher robot circuit. This is the L29 3D motor driver. This is a relay. This is Arduino. Here it is a submersible water pump. Here we are using a breadboards to connecting the circuits for 12 volts and 5 volts. This is a ground. This is all are connected. This complete breadboard will be taken as a ground, and here the line is the vertical line. The vertical line is 5 volts and another vertical line is 12 volts. Yeah, this is a flame sensor. Here we are using 3 flame sensors, and here we are also using one stepper motor. So flame sensors having 3 terminals. Middle one is ground. Here it is a 5 volts supply. Here it is the signal pin. This one is a signal pin. Flame sensor is used to detect the fire source and other bright light source. The sensor basically detects the infrared light. Its wavelength among 760 nanometers to 1100 nanometers. Flame sensor having 3 terminals, VCC, ground and digital output pin. Relay is a switch which controls the circuits electromagnetically. The relay having 6 pins: input, ground, power supply, normally closed, normally opened and common terminal. Here the relay operation is when fire detects, the servo motor and the submersible water pump both will be works together. For that purpose, the relay is used in this project. Submersible water pump is a low cost and small size water pump which can operate from 2.5 volts to 6 volts. It took up 120 liters per hour. It consumes very low current, 220 milliamperes. Submersible water pump. A submersible water pump push water to the surface by converting rotational energy into kinetic energy. That kinetic energy is converted into pressure energy. Here this is the servo motor. Here servo motor have three terminals. The brown wire indicates ground and red wire indicates 5 volts and orange wire indicates signal pin. The servo motor works on the principle of pulse width modulation. Actually servo motor rotates 0 degrees to 180 degrees. This is a L29 3D motor driver. It having a 4 outputs. This is output 1, output 2, output 3, output 4. Here we are connecting this L2 3D9 motor driver is responsible for the movement of robot. And the voltage and the operating range is from 5 volts to 36 volts. So guys, now move on to the flame sensor. So first of all we connect supply voltage. Supply voltage is connected to the red wire, and then we can go to ground. Ground wise we are taking a black wire, and then move on to the signal. Here signal pin we are connected to the green color wire. Yes. Now we want to fix the flame sensor to the robot body. So guys, now we want to fix the connections into the breadboard. This is a 5 volts connected on breadboard. Here the 5 volts column is there. We are connected to the 5 volts red wire, and then here the another sensor. This is also connected to the 5 volts onto the another breadboard. Here also another sensor. This is also connected to the 5 volts on another breadboard. So we fix both three flame sensors are 5 volts are connected to the single breadboard on 5 volts column. Then we want to fix the ground. This is the ground pin. These three ground pins are connected to the ground breadboard. So we want to connect this pin to the ground sockets. Here we are fix the ground connections. Now remaining three connecting wires are signals. These signal wires are connected to the Arduino board. This is the here three flame sensors are there. This is middle one, right, left. Middle one is connected to the 8th pin on Arduino Uno. So where is the 8th pin? This is the 8th pin. Here we are fixed the 8th pin, and the right flame sensor are connected to the 9th pin. Here there is a 9th pin, and left flame sensor are connected to the 10th pin. So the flame sensors are connection will be completed. Now move on to the next we want to move on to the L29 3D motor driver. Here the L29 3D motor driver. Check once. This is L29 3D motor driver. These two pins are connected to the robot BO motors to movement of the robot. This is output 3, output 4, output 1 and output 2. Here we are connected alternatively, we are connected the connection pins because of movement of the robot. Here we are connecting red pin to the output 4, and it means 5 volts voltage. It is a positive voltage. Here the red wire is connected to the output 4 and black wire is connected to the output 3. Here alternatively these two pins are oppositely connected to the this two outputs. Here the black pin is connected to the output 1. This is because we are connecting opposite connections. So here the output 2 is connected to the red pin. This is for the movement of a robot. Here the 4 pins are there. Here the 4 pins are there. Input 1, input 2, input 3 and input 4. These 4 pins are connected to the Arduino Uno 2, 3, 4, 5. Second, third, fourth, fifth. These four pins are connected to L29 3D motor driver input 1, input 2, input 3 and input 4. So now we want to connect those pins to the Arduino. Just wait a second. So these 4 pins are connected to the Arduino Uno. These 4 pins. This is connected to the second pin. This is connected to the third pin. This is connected to the fourth pin. This is connected to the fifth pin. Now come on and we connect it to the Arduino. Second pin, third pin. This is the fourth pin. And this is the fifth pin. This will give commands to the L29 3D motors to the movement of the robot. Next we move on to the relay. This is the relay. Here this set 3 terminals are there. One is normally closed, another one is normally opened, and another pin is common pin. Here we have 4 pins are there. Actually we connected only 3 pins. One is supply 5 volts. Input 1 and input 2 are there. You consider either 1 or 2. Only single terminal we want to be considered. Either input 1 or input 2. Wheels terminals will be connected to the output 1 and output 2. Another wheels terminals are connected to the output 3 and output 4. Here the 4 pins are there. The 4 pins are input 1, input 2, input 3 and input 4. These 4 pins are connected to the Arduino. Arduino pin 2, pin 3, pin 4, pin 5. Input 1 is connected to the pin 2. Input 2 is connected to the pin 3. Input 3 is connected to the pin 4. Input 4 is connected to the pin 5. These 4 pins are connected to the Arduino 4 pins from 2 to 5. So let's move on to the session. So this is our robot. So first of all we go to body of the robot. So this is the body of the robot. Here we have using 4 wheels. 4 wheels are connected to the BO motors. Here we have 4 BO motors. 2 BO motors are connected. So L29 3D motor driver having a two power supply pins. One is 5 volts, another one is 12 volts. Here we are using a 12 volts power supply. This is the 12 volts pin, 12 volts power supply pin, and this is the ground pin. So we want to connect 12 volts power supply pin. Here this said column is 12 volts. So we connect it to the 12 volts power supply. This is the ground pin. So we want to connect to the ground. Successfully connected we are connected the L29 3D motor driver. All connections will be done from the L29 3D motor driver. Now we move on to the relay. This is the relay. Relay having 3 terminals, and this side having inputs supply voltage, VCC and ground pin, and 2 inputs are there here. Actually we are connecting only single input, that is input 1. Either we are connected input 1 or input 2 based on our requirement. So VCC is connected to the 5 volts and ground is connected to the ground pin. 5 volts power supply. So we connected to the 5 volts, and we are connected to the ground pin, and we connected to the input pin. Input pin will be taken as a green pin. Here the input pin is connected to the 7th pin on Arduino. So first of all we fix the power supply. This is the 5 volts power supply. Here the 5 volts is on the Arduino. We are fix the 5 volts. Then we want to fix ground. So this pin will be connected to the ground pin. Here the ground pin is there. Now finally this input pin is connected on Arduino on 7th pin. We want to connect 7th pin on Arduino. This is the 7th pin. Yeah. Here the relay having 3 terminals. One is normally opened and common terminal normally closed. Normally opened pin is connected to the submersible pump on red wire. This is the submersible pump. And common terminal is connected to the 9 volts power supply. The another terminal of the submersible water pump is connected to the ground pin on Arduino. This is the ground pin. This is the servo motor. It rotates 0 degrees to 180 degrees. Here we are using this servo motor is to spray the movement direction of water control pipe. It is used to movement control in this robot. Spraying of movement control. This is having 3 terminals. The servo motor having a 3 terminals. One is signal pin, another one is a 5 volt supply, another one is a ground. Now the signal pin is connected to the 11th pin on Arduino. Here the 11th pin. We are connected signal pin on Arduino on 11th pin. Now we want to connected this 5 volts on breadboard 5 volts column line. Then the ground pin. So now we want to give an power supply to the Arduino. Here the Vin is given to the 5 volts. 5 volts is connected to the 5 volts of on Arduino board. Arduino board to breadboard. Here the another 5 volts pin is there. That 5 volts pin is connected to the breadboard 5 volts column line. Then the ground pin is connected to the
water pump.
The ground pin is connected to the water pump. Now this is the 5 volts power supply voltage connected on breadboard 5 volts. Now remaining ground pin connected to the ground pin on ground. Now we apply the power supplies to the breadboard. Here the 12 volts power supply applied from the batteries and 5 volts power supply applied from the this set batteries. This is for 12 volts. This is for 5 volts. This is the supply connection for the metal detector. It is connected on 12 volts. This is for the movement of Vivo motor operation. This is connected to the 12 volts.
Automatically ABS means it will provide the exact value. There is no point values or floating values. So here it will be used for the adjust for small changes for remove spikes. Next, coming to the next year, if the skip is greater than 64, until if the skips are less than 64, this process will be done. If the skips is greater than 64, it will break will be off. So in case of prolonged skipping, if the skipping is more, at that time we done this process sum equal to sum, it will be left shift 6. Next skip equal to 0. This is the process for the remove spikes. Next, coming to the last if block, if difference equal to is equal to 0, some specific buzzer time value will be defined. Else buzzer period will be taken as average sum by 2 into ABS of difference. That means difference is not 0. Diff equal to not 0, we taken this average sum. So this is a code for metal detector. In this mainly metal detector, we are using the coil and charging capacitance. Based on the coil turns measurements, will charging the capacitor. The charging the capacitor will go through the coil. If the metal is there, the flux will be disturbed. By this, we will send the out buzzer as the output. By this, we can detect the metals, and finally this metal detector code and fire extinguisher code will be dumped into the Arduino by connecting the USB cable, then operate the project. This is the software code for the both the fire extinguishing and metal detector.
Robot code is written for the every component and dumped to the Arduino Uno. And another code is also there. Another code is for the metal detector. Now we want to dump this code into the Arduino board. First of all, we want to USB cable to connect between the laptop and to the Arduino board. After connection of laptop to the Arduino board, a indicator light will be glow. This is the indication. After dumping of code, we got results successfully, and the result is shown in the video. Please.